All right, so we're looking at circumference, which you guys should already know what circumference is. What is it? Distance around a circle. Very good. And then we're also going to look at arc length. So arc length is essentially just a portion of the circumference. So rather than finding the whole distance around a circle, if I give you just a chunk of it, could you find how long that one chunk is? Cool? Okay? All right. So some formulas for you here. First formula you've got is the circumference. This is one that you guys have probably already seen before. We already know that the circumference is the distance all the way around the outside. This part of the formula right here is the one that you've probably used the most, 2 times pi times r, 2 pi r. Notice that we also can use pi times diameter because technically 2 times the radius is a diameter, right? So I can get rid of the 2 and the r and replace it with a diameter. The formula that I'll use most often is going to be the 2 pi r, just because it's kind of the universal one that most classes are going to use. When you guys are finding an arc length, so notice that in the second picture, rather than highlighting the whole entire distance around, I've said, hey, I just want to find a portion of that distance. Okay? You can do that by setting up similar ratios. So in other words, if you were to take the arc length distance and put it as a fraction around the whole entire thing, basically what you're saying is how much of, like, what portion of the pi does that section make up? Does that make sense? Right? So if I told you that I had an arc length of 16 and the whole entire circumference is 48, how much of the circle does that one chunk make up? If the section is 16 and the whole circumference is 48. Careful. What are you going to do? Again, so I'm telling you here, so pay attention here. If I tell you that this chunk of the circle is 16, and if I also tell you that the whole entire circumference is 48, how much of the circle have you, in other words, how much of the pie have you eaten? A third of the pie, right? Because you would have 16 over 48 is how much of the pie you've eaten, right? That's kind of the logic you're using here, is fractions. Notice that you can get that same method by, if I had told you that this angle was 120, why is that the same thing as a third of the pie? Because it's out of, and 120 out of 360 is the same thing as 1/3, right? So you can find what portion of the pie you've eaten either with knowing a portion of the distance around to the circumference, or you could do it with the angle measure out of the whole 360, right? They're simplifying down to the same exact portion of the circle that you've eaten. Does that make sense? So that's what this formula is down here. This formula down here says that you can take the arc length and divide it by the entire circumference. That was your 16 divided by 48. That will tell you what portion of the circle we're dealing with here. That should be equal to whatever your angle is that forms that piece over 360. Those should simplify down to the same exact portions of the circle. Does anyone have any questions on that? No? Okay. So let's take a look at some examples. Our first example is simply looking at, can you find circumference or can you deal with circumference? Not even looking at the arc length yet. All right. So we want to solve the following questions for a stool that has a circular seat. So for part A, I'm saying we want to find the circumference of a seat that has a radius of 9 inches. So you see the word circumference and you're thinking, okay, I know what formula this is. What formula do we use here? Circumference equals 2 pi r. You could do the diameter instead. Yeah, you can, as long as you drop the 2. In this case, though, we're given the radius, so we would use 2 times pi times 9, right? which equals 18 pi. Okay, now something we have to talk about is how are you going to give your answers? There's 3 different ways that I could ask for an answer in this section. Either I'm going to ask you just to leave your answer in terms of pi. So in other words, you would just leave it here. That is the best answer technically, mathematically speaking, because it's exact, right? You guys should all know does pi have an end to its decimal? 3.14159 blah, 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 forever and ever and ever, right? So if you actually calculate 18 times pi, is there any physical way that you're going to be able to write down that whole entire solution? No. You're going to have to round it at some point, and it becomes an exact when you do that, right? But there is a benefit to rounding it, because when I say 18 pi, do you really have a good feel for how many inches that actually is? No. So in some cases, it's nicer to actually give it as a decimal. It is an approximation, but it's one thing we can do. Now, in some of your classes, in fact, up to this point, most of your teachers probably, when you dealt with pi, told you to use what value for pi? 3.14, right? Which means, though, that you're not going to have a very exact answer because you're only using 2 decimal places out of infinity to get that answer, right? But that is a way that we will sometimes do this. So another method I might ask for the answer is for you to use pi is approximately 3.14. In which case, what do you guys get for the circumference then? So you guys would get the circumference is approximately 18 times 3.14. What is that? 56.52. Okay. So now I've got a better idea of how many inches that is, but I know that I have a bad round-off error because I used an approximation of pi. Take a look at your calculators. Do you guys see a button that uses pi? Everyone find that on their calculator? So find the button that looks like a pi. If you have a graphing calculator, it's going to be in yellow underneath the clear sign. And you're going to have to press your second key. I want everyone to press their pi button and tell me, do you get an approximation or do you get a string of numbers that you're assuming goes off the screen and continues? Like the calculator knows what pi is, right? Yeah, and so basically what happens is you could, instead of using a 3.14 approximation, you could get something that says or round to nearest hundredth. But I haven't told you here, hold on. I haven't told you here to use the pi approximation of 3.14, right? So what you guys are going to do is you're going to use 18 pi and put this on using your calculator. 1 second. All right, so type in 18 times pi on your calculator and tell me what you get. Ethan? Are you here? Okay, yeah. After first lunch? Okay, so what do you get? You should be getting still 56.5, but what do you get after that? 4, 8, blah, 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 which means if I'm rounding to the nearest hundredth, I'm going to round the 4 up to a 5. Now notice, did you get the same approximation when you used 3.14 versus 56.55? No, you did not get the same approximation. Which one of these is actually better? This one, because it used the entire pi and then you rounded. Whereas here you used an approximation and calculated. That gives you an approximation into an even worse approximation, right? Keep that in mind. We will still use this one because sometimes it's just, you know, it's nice just to use a 3.14 approximation and it's okay. But you need to be ready to also use the exact version to get a better approximation or just leave it in terms of pi for a perfect answer. Make sure you're reading what the problem wants. Okay? So, for part B, it says find the radius of a seat with a circumference of 52 inches. What is different about this problem? It gives you the circumference first. How do you approach this problem? Very good. Yeah, so he said 52 is equal to 2 pi r. He is still using the same exact circumference formula. That part does not change. All that changes is the fact that instead of being given the radius to plug in, I've been given the circumference that I plug in. So how am I going to solve for r? I'm trying to get this guy alone.
Why don't you use just the flat 52?
What? Because the circumference is just flat 52? Yeah.
Divide them?
Divide by?
52?
What am I trying to get alone?
R?
So is the 52 attached to the r? Which means I don't need to move the 52. What do I need to move? 2 and pi. So what I want to do is actually divide by 2 pi, not 52, right? Because I want to move the stuff that's attached to the r. So if I do that, I now get r by itself. So I'm going to have r equals, and when I'm looking at this solution, what can I simplify here? 52 and 2 become 26, but I'm still dividing by pi, right? That pi stays in the denominator. All right, so this is our perfect answer, but does it give us a good number sense of how long that actually is? No, it does not, right? So what I really could do, again, you could have two different ways you could give the answer. What if I want you to use pi is approximately 3.14? What is that going to look like then? Your radius is going to be approximately 26 divided by 3.14. And if you calculate that, you're going to get an approximation again, but remember it's not a good approximation, as perfect as it could be, right? So we get r is approximately, and we'll just round it to 8.28, and I'll go to 4 decimal places, so 0.3. What's the other way I could do this? Divide by the actual pi button. And again, in the directions, what that is going to look like is they're going to tell you to round to 4 decimal places. And a lot of people get confused about, well, how do I know whether or not I want to use 3.14 to round that, or if I want to just use the pi button? If they want you to use 3.14, they're going to tell you use 3. Oh, and I didn't write the 1 in there. They're going to tell you to use 3.14. If they don't specifically say use 3.14, but they tell you to round, something like this, that's when you use the pi button on your calculator. So again, if they want you to use this approximation, you should see this exact thing somewhere in the statement. Make sense? So never use 3.14 unless that statement is specifically written down. If all they say is round to 4 decimal places or round to however many decimal places, then you make the assumption that, okay, I'm rounding, but I'm rounding off of actual pi. So in other words, you would be doing the radius is equal to 26 divided by pi, and you would be using your calculator button on pi. All right, so what do we get this time? It is going to be an approximation, but we get 26 divided by pi is 8.2761, if you round that. Notice how far off these are, you guys. Like, look at the decimals here. The only decimals that match are the tenths place, right? From there, it gets off. So you really want to be watching that. You are going to lose points on a test if you don't give it specifically how I've asked for it, all right? So on a test, if I ask you for this problem and I say to round to the nearest 4 decimal places and I don't say anything about 3.14, and if you use 3.14, you're going to lose at least a point for not following through on the problem exactly how I've specified. So really watch how they want that answer given. Okay? All right. So here it says to find the length of arc AB. I wasn't able to do this on my computer as far as notation goes, but your book is going to be using a notation where instead of saying find the length of arc AB, they're going to say find, they're not going to say the length of arc, they're just going to say find arc AB, and the way that they're going to denote it is with an arc over AB. Okay, we assume, you guys, because the question is, well, Ms. Krejci, if I'm trying to find arc AB, are you trying to get me to find the distance here, or are you trying to get me to find the distance around the outside? What do you think you would always do unless told otherwise? The smaller version, yep. So you'll always be finding that smaller arc unless, and I'll show you the notation for it on a later slide, unless they use a very specific notation, which will force you to go around the outside, and I'll talk about that, okay? So I know that when I'm looking at this thing, I am trying to find the distance, the short distance between A and B on the arc. So I'm trying to find that guy right there. All right. So anytime that I don't know what I'm looking for, or the length, what do I put in place of that length? X. Very good. I kind of worded that weird, sorry. So I'm going to put a variable on my missing unknown information, right? Now, we're dealing with arc length, which remember, this is, you're trying to write ratios that would describe how much of the pie have you eaten, right? Yeah? So pretend that this is a piece of pie, this little slice right here, and I'm asking, how much of this have you eaten? All right? So what's one fraction that you could write to describe how much of the pie you have eaten? And how are you getting 1/6? Backwards. But backwards. 60 on top, right? Yeah. So 60 divided by, and if I was trying to describe how much of the pie I've eaten, what would I put 60 over to describe the whole pie? 360, right? I'd put it over the whole entire angle. That means that how much of the pie have I eaten? 1/6 of the pie. Now I can use that to figure out what X is, right? Do you have enough information to describe the whole entire outside of the circle? What do I mean by the whole entire distance around the outside? What is that? What is it called? Circumference. Do you have enough information to find the circumference? Okay, so I know that I can find the circumference by doing 2 times pi times the radius, which is 16. Now follow your directions correctly. What should I be doing with that pi? Should I be leaving it with pi? Should I be using an approximation? Right, so when I calculate this, I'm going to calculate it as 2 times 3.14 times 16. What is that? All right, so why did I find the whole circumference? What was the point of that? Again, think of how much of the pie have you eaten, right? So we know, we're trying to figure out in terms of the distance. Yes, you could do that. So I'm going to kind of talk through it in the formula that I put up on the other slide. But really, you know, you can think through it intuitively. You don't have to use the exact formula that I gave you on the other slide. Isn't it true that if this piece makes up 1/6 of the circle, and you know the entire circumference is 100.48, how can I find 1/6 of 100.48? So X is going to equal 1/6 of the whole circumference. Do you guys see that? Does that make sense to everyone? Using the angle, you found out how much of the circle that pizza piece made. And then you said, okay, well then I should be able to find the whole circumference and take 1/6 of it because that's how much of the circle this piece makes up. Right? All right, so 1/6 of the circumference is going to be 1/6 of 100.48, which is what is it? I'm getting 16. Is it possible for me to write this as an exact? Because it's a repeated decimal, right? So I can write this as 16.74, and then you'll notice your calculator is giving you like 66667. That 7 is just because they're rounding up that final 6, but you're assuming that that string is actually continuing as 6s forever. So with the bar over the top keeps it exact. So that means I have found x and I am done. Yeah? All right, so let's keep on going. So we want to find the indicated measure, and how am I going to be giving my answers? In terms of pi, which means am I doing any approximations or decimals? No, I am just leaving that pi symbol in there, right? Okay. Let's draw a circle really quick and kind of interpret it. So mine's going to be kind of small, but got a circle. And I'm going to look at what I'm told about it. So I am told that the central angle, I'm trying to find the central angle formed by an arc length of 16 for a circle of diameter 10. If I have a diameter 10, how big is the radius? 5. All right, now something that I want you guys to kind of pay attention to here. You can use logic to kind of guesstimate about where you think your angle should be, and then do the calculations and double check your answer. You can use kind of a logic guess and check here. Take a look at this distance 5. Could I measure that out on a string? Yeah? All right, if I measure that out on a string, and I start to take that same string and I wrap it around the outside of the circle, you can kind of see how 5 would maybe fit to right here. Do you see that? If I start right here and I take that same distance 5 and I wrap it, it looks like it kind of goes to right there. Yeah? Okay, now how many 5s, if I want to make an arc length of 16, about how many 5s do I want to fit around the circle? So in other words, I could take that 5 and visualize, and you're just kind of guesstimating it with your hand, wrapping around 3 of those 5. So there's 1. It looks to me like there's 2-ish right there. And then 3 and a little bit more is going to take me just past 180. Do you guys see that? Okay, now you don't want to get stuck on it because you are guesstimating it. So you don't want to like say, okay, it has to be, it's going to be around 180. You can kind of see that, but it's going to be near 180. It might be a little bit less. It might be a little bit more. It's kind of hard to tell exactly where those 5s are going to fall. But I at least know that I'm not expecting like a 20-degree angle, right?
Why are we using this string?
So that you guys can check your answer. What I am showing here is, do you see how that kind of shows you how big that angle should be? Ish. I'm doing this because when I check my answer, if I get a 20-degree angle, do I know something's wrong?
Yes.
Yes. So I am just doing this as kind of a way to guess and check my answer. I'm saying I know my angle needs to be like kind of around 180. If I get something way small or like way big, like 360 degrees, I know I've done something wrong in my calculations. Okay? So it's just a method that you can use to kind of see if your answer makes sense. Okay? All right. Now I am trying to find the central angle, which means that I am trying to find this angle right there, given that, and what else do I know that I can put on my figure? What have I been told? The length of the arc formed by that angle is 16. All right. Do you have enough information right now to figure out how much of the pie I've eaten? What fraction of the pie have I eaten? What information do you know to find that out? Can you use the angles? You could find the circumference. So let's kind of talk through it. You don't know the angle of the interior, so you can't put it over 360 and tell me the exact fraction that makes up that circle, right? Do you see why you can't do that? But you do know this distance around the outside is 16, and if I knew the whole distance around, I could figure out how much of the circle that makes up. Do you know what the whole distance around is, or do you have enough information for that? Yeah, so you guys can find the circumference by doing 2 times pi times the radius, which is 5. So my circumference is, and remember, I'm leaving things in terms of pi right now, so 10 pi is my circumference. So what is the fraction of the circle that I am dealing with then? How much of the circle have I eaten? How much of the portion have I eaten? There's only two numbers that describe that slice. X, which we don't know. What's the other number that describes the portion that I have taken? 16, right? I have eaten 16 out of how much of that circle? Out of 10 pi. It's kind of confusing because I'm leaving it in terms of pi, so it's not like a number, but this is still saying that I have eaten 16 out of the whole 10 pi that makes up the circumference of the circle, right? I'm going to still leave it in terms of pi. You guys kind of just have to get past it. You're not going to come down to a nice number like 1/6 or 1/3. That's not going to happen, but this still is a fraction that represents a portion of the circle to the whole circle, right? How can I simplify this? What number divides both 16 and 10? 2, so I'm left with 8 divided by 5 pi. That is how much of the circle I have eaten. How can I use that to find my angle x? To help you through this, kind of pretend that this came down to 1/3. Just pretend with me for a second, okay? If this was 1/3, how would you determine how big x was? You would take 1/3 of 360, right?
So you just take 5 pi.
Not even 5 pi. You're going to take, so again, your fraction, I said, if your fraction was 1/3, you would literally take 1/3 times 360, right? So all you guys have to do is take 8 over 5 pi of 360. Again, this represents the portion of your circle, right? This is the portion of the circle, and you want, in terms of angles, to take that same portion of your whole entire angle, 360. Is there anyone who doesn't see that? It's hard to see because it's in terms of pi. Again, work with me and try and picture as though that was a 1/3, then you would do 1/3 of 360 to find that portion of 360. Having 8 over 5 pi is still a number. Put it in on your calculator really quick. What is 8 divided by 5 pi? And you guys are going to have to put parentheses around. If you're calculating 5 pi, you need to make sure you put parentheses around the 5 pi to make sure the pi stays in the denominator in your calculations. So you guys should be typing in 8 division key, open up a parenthesis, type in 5 second pi, end your parenthesis. You should get that is 0.509, right? So in other words, that is almost half of the circle. Do you see that? 8 over 5 pi is approximately a half. Does that look right according to our picture? So we're taking approximately half of 360 to figure out what angle we're getting, right? Now we need to leave it in terms of pi because of the way the question is. That's what makes this problem tricky, is that rather than saying like, it's about a half of the circle, I'm saying it's 8 over 5 pi, which is about a half. It's just in a kind of more difficult form. So if I want to do this calculation here, but I don't want to lose the pi, this is going to turn into 8 times 360 divided by 5 pi. So what I want to do is reduce any numbers I can. So does this 5 on the bottom, can I simplify it with either of these numbers up here? The 360. So how many times does 5 go into 360? And you can just divide it out on your calculator if you don't know off the top of your head. But it goes into it 72 times, which means that this is 8 times 72 divided by pi, because I lost the 5 in the denominator. So in terms of pi, this answer is 8 divided by 72, or I'm sorry, 8 times 72, which is 576 divided by pi. I am saying that I'm dealing with that portion of the circle in terms of angles. Now remember I said that I was expecting my answer to be about 180 degrees. So if you want to check that, just take 576 and divide it by pi and check your answer. What are you guys getting? 183.3? So does that kind of seem about where I was expecting it to be? Yeah, so that means I've done this okay because I didn't get, like if I had gotten 10 degrees or if I had gotten a huge angle, that would have been not where I was expecting it to be, and I would check my work. All right, so let's take a look at part B. The circumference of a circle, we want to find the circumference of a circle given that the central angle formed by an arc length of 11 is 45 degrees. So we have to kind of reverse our logic in this part. In the past two examples, I've been asking you to find the portion of a hole, either whether that's the arc length that's the portion or the angle that's the portion. But this time I'm asking you to find the whole circumference, right? Similar logic, so you guys are going to have to think through it a little bit, but we're going to have to kind of just reverse one thing. So let's really quickly draw a circle so we can see what we're working with. I want to find the circumference of that circle. I'm assuming that I'm working with a central angle of 45 degrees, so make sure you draw it to look like 45, right? 45 is half of 90, so it should look something like that. So I've got a 45-degree angle in here, and the arc length formed by that is what? So I would put the 11 on that little piece of arc outside of the 45-degree angle. Do you guys have enough information to tell me how much of the circle that pizza piece is making up? Can you use the angle or can you use the arc length? So if you were to use the arc length and you wanted to say how much that pizza piece would make up, you'd have to take 11 and divide it by... the 11's not talking about an angle. So I'd want to take the 11 and divide it by part of the distance around to the circumference, the whole distance around, okay? It would not, I heard somebody say 360. Keep in mind, it doesn't make sense to take an arc length of 11 and divide it by a 360 that's an angle. They have to be similar measurements, right? So either you have to take an angle and divide it by an angle, or you have to take a length and divide it by a length. Do you know the circumference? Do you have enough information to find the circumference right off the bat? That's what we're looking for. So I can't use that 11, but can I use the 45 to figure out what portion of the circle I'm working with here? How can I do that? 45 divided by 360, which is? How many times does 45 go into 360? How many times? 18. Okay. So this is what? What kind of a fraction is this then? 1 over, whoa, not that. Sorry. All right. This fraction simplifies down to 1/8. That means that this little pizza pie right here takes up 1/8 of the whole circle, right? That means that 11 is 1/8 of the whole circle. So how are you going to find the circumference knowing that the 11 is making up 1/8 of it? Does everyone see that? The circumference should then equal 8 of the 11s, which is 88. Does everyone see that? So you really want to think intuitively about it. Your first goal is to find how much have I eaten of the pizza, either taking the arc length over the circumference or by taking your central angle out of 360. Whichever one you can do is how you're going to find how much of the pie you've eaten, right? Once you know how much of the pie you've eaten, you want to ask yourself, how can you use that number to figure out the missing part? Any questions on that? Okay, so let's look at the next example. This is the one I was talking about where this time I am not trying to find necessarily the arc length, the smallest arc length, or I'm not given the smallest arc length. The notation for this, you guys, I didn't put it on here, but I just want you to see it. The notation they're going to use to signify that they want the bigger arc is they're going to say TUV, TUV with an arc length over it, that's 30. Because if I just said TV, I would be talking about this little piece right here, right? Remember I said unless I give you a special notation, you're assuming the smallest piece, right? So if I just said the arc length of TV, that would be this. By putting the U in there, what it does is it forces you to go, instead of going straight from T to V, you have to follow the order of the letters. So you would have to go around and do T, follow to U, then to V. That's what forces you around the outside on the bigger piece. So be ready for that notation as well. Okay, guys, so this one has kind of a little trick. So far, when we've been doing the pizza slices, the angle we've been given has matched the arc length that we wanted, right? Notice that this time we have kind of a reverse scenario. The angle I want to find does not correlate with the arc around the outside, right? In other words, the piece of the pie that this little angle makes up is definitely not the same piece of the pie that the 30 makes up, right? But you still have enough to work with. So if I asked you to find how much of the pie, what's the ratio of the pie that you guys have eaten if you were dealing with, let's say, the smaller slice? How would you find that? What would you need to know in order to find how much of the pie you've eaten out of the smaller slice? You need a portion that you've eaten, which would be this arc length right here. And then you would need the whole, right? Which would be the circumference. Do you have enough information to find the circumference? Okay, how do you find, let's start there. How do you find the circumference? Times 6.3. But I was told not to use pi, I was told to use 3.14, right? So I will be typing into my calculator 2 times 3.14 times 6.3. Okay? 6.3. If you look at the radius on the diagram, right? Did I? I said 3.14, did I? That's all right. Sorry. I wrote it correctly. All right, so this gives you 39.564. All right, so the problem is that I'm asking you how much of the pie does this make up? So I would need to know what this chunk is. Can I find what arc TV is? How do I find arc TV now? So I've said that the whole entire distance around is 39.564, and I know that the outside arc is 30, which means that this arc, if I want my whole entire circumference to add up to 39.564, what does that need to be? Right, it's going to be the circumference, 39.564, minus that outer loop to see what I'm left with, right? Which is 9.564. So if I look at that, I've got 9.564 here now. Do I have enough information to determine how much of this circle, how much of the pie I've eaten? What's my fraction to determine how much I've eaten? This should not, you guys, I could go to a third grader and ask them this. And I'm not kidding when I say that.
Wait, what?
You have enough information to tell me how much of the pie you've eaten. What? Not exactly. I need an exact number, guys. This is not difficult math right now. And I'm going to call you out on it. You guys are just not trying at this point. You're waiting for me to spoon feed you an answer, and you're sitting there and you're staring at it pretending like you're actually trying. But like I said, a third grader could tell me this. How much of the pie have you eaten? Well, you've eaten 9.654 out of how much?
30.
Do you see what I'm saying? I could go to a third grader. Think, you guys. Don't wait for me to just spoon feed it to you. That's why your class average is so much lower than my other classes. They participate in the questions I'm asking. They give me answers. They come up with ideas. You guys wait for me to just deliver it to you. That's not enough. So the portion that I have eaten is 9.654. Did I switch it? Oh, and I switched it up there earlier, didn't I? All right. So I accidentally got dyslexic up here, it looks like, and this should be 564. So that's what I'm going to use down here, 9.564. That's how much of around the outside I've eaten out of the whole outside is 39.564.
Is this on this lesson?
This week, no. All right, so we take 9.564 divided by 39.564, and we get kind of a big, ugly number. So I'm actually, to keep things exact for right now, I'm going to just leave it as this. Right? Because if I were to divide that out, I'd get a big string of decimals that I couldn't keep exact, whereas, is this currently exact? Yes. All right, so that's how much of the circle I'm using. I am using this much out of this much, which means how do I find the angle? How much of the angle out of how much? So wouldn't I just take this fraction right here, whatever this is, and multiply it by 360? Do we see that? I am finding this right here tells me how much of the circle I've used, so I want to use that same amount of 360. It's confusing again because it's not like a clear 1/3 of 360 or 1/4 of 360. But it still is a fraction less than 1. It still is telling you how much of that whole circle, whoa, I thought I was on the pointer. It still is telling you how much of the whole circle you've used out of the whole, right? So this is something I'm going to type in now, and then I'm going to just give an approximation because it looks like it doesn't end up being quite exact. But I multiply that by 360, and I get 87 point, and let's round it to 4 decimal places for this one, 0.246 degrees. It's about how much I've used. What should you expect your answers to be between? Like, what would be an angle measure that was far too big? If you got an answer that was, I could have a 100-degree angle. I see what you're saying. In this picture, yeah, if it's drawn to scale, it couldn't be 100. But I'm asking in any picture whatsoever, when does an angle get too big? When it's over 360. If you get an angle bigger than 360, that is a problem. Right? You can't have more than 360 in a circle. Okay, one more problem. All right, so you are told that you have a tire that has an inner rim diameter of 22 inches, and the tire is 5 inches thick. So you, if you were to draw this, would have a circle whose inner diameter, meaning the whole entire from rim to rim, that would be 22, right? So then the radius is 11. So if I drew out my radius, that would be 11. But that's just the inner rim, so I still have a 5-inch tire around the outside of that. Give me a second. I kind of struggle sometimes with drawing the second part and making it look not great, but you guys can see what's going on, right? So we're assuming that that's 5 inches all the way around. I know it gets thin right there, but that's just because of my tools that I have. All right. So if the tire is 5 inches thick, then that's adding an extra 5 inches onto my total radius, right? So what is my overall radius on this whole entire thing? 16. Very good. So the whole radius is going to be 16 from the start all the way out to the edge of the tire. In terms of inches, right? So what this question is asking is how many times would I have to, how many revolutions of the wheel does it take to travel 1 full mile? Okay, so basically what you guys have to be able to say is, what is 1 revolution in terms of distance? Because a lot of you guys will understand a revolution is 1 full turn of the tire. What distance do you travel in 1 full turn of any tire? What is that the same thing as for that tire? That's the circumference that you have traveled, right? If you picture rolling 1 wheel forward, you're traveling the whole distance around the outside of the circle, which is 1 full circumference. So 1 revolution is equal to 1 circumference. And 1 circumference is 2 times pi times the radius. So 2 times pi times our radius of the whole circle. Because remember, you want to see how far is the whole wheel traveled? That's the whole entire radius of 16, not just the inner circle. So I've traveled 32 pi, but this is in terms of inches, right? And I want to see how much this fits into a mile. In inches in a mile, that's not an obvious conversion. But I did give you a conversion in terms of feet, right? So could you convert inches to feet pretty easily? Yeah. You should be able to. Again, this is something you've done in science. This is something you've done in grade school, middle school. I'll remind you, though. All right. If you want to get rid of inches, I currently have inches in the numerator of my fraction here, which means to cancel it, I want my inches in the denominator. And then so that's going to allow me to cancel out that unit, and I want to put whatever unit I want to pick up on top. So what unit did I say I want to pick up? Okay? So now all I have to do, now that I know which units I want in top and bottom, now I just say, what is that conversion? So in other words, how many feet to how many inches? How many feet to how many inches? What would be a fraction that would describe 1 foot to 12 inches? Okay, so that means that currently I have a circumference that is 32 pi over 12 feet. But I can simplify that. What number divides both 32 and 12? Bigger than 2? 4. So 32 divided by 4 is 8. I still have a pi. 12 divided by 4? So I've got 8 pi over 3 feet. Okay? That's how far I travel in 1 revolution. All right? Yes, it's in terms of pi, so it's sort of hard to get your mind around how big that is, but you're traveling a certain distance in 1 revolution. So if I asked you how many of those distances fit into a mile, what would you do? Divide? So it is exact. 8 pi over 3 is exact.
I mean, like an actual number.
That is an actual number. Remember, if you actually plug in pi and you round it, is that exact anymore? So I actually don't want to take this out of pi right now. Even though it looks weird, that still represents the same exact number as it would as a decimal, and it's keeping it perfect. Okay? Let's calculate it just so you guys can kind of get your mind around it. If you type in 8 pi divided by 3, you get 8.3775, blah, 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 blah. How many times is that going to fit in a mile? How do you figure that out? What's the calculation that you do? Yeah, you take how long a mile is in terms of feet, right? And we want to see how many times this thing right here is fitting into that mile, because that will tell me how many times I revolve this distance in a mile, right? Now, like I said, a lot of you guys are really going to want to write the decimal because it just looks more friendly to you, but then you're rounding your answer. So you can still just divide by 8 pi divided by 3. You just have to be very careful about how you punch it into your calculator. So when you're doing this in your calculator, the sequence of steps that you should follow should be 5280, division key, and then what do you think you have to do?
Well, 8 parentheses.
Parentheses,
8 pi divided
8 pi divided
by 3.
by 3, and then end your parentheses. That way your calculator knows to find this value first and then divide it. If you don't put the parentheses around it, it's going to do first come, first serve. So it's going to do 5280 divided by 8 pi over 3 divided by 3, which in this case probably, does that work? Yeah, so if you do that calculation, you guys should get 630.25, about that many revolutions, right? Will fit in a mile. Oh, shoot, sorry. I didn't realize I was all the way down there in the sky. Let me squeeze that in up here. Am I in the stuff yet? Nope. Getting close, though. So this is 630.25 approximately revolutions. And that would be your answer. Okay? All right. So here's your homework for that. I'll post it on Schoology, but again, that's not due until Monday, so I don't want you guys to worry about that until after you've done the quest. You should focus on studying for the quest first, which is what we're going to do now.